And good evening once again, and welcome to the other side of midnight, where we explore that dimension between imagination and reason and things that, I guess, go bump in the night. I have a very special guest tonight, which we'll get to shortly, but I do want to take care of a couple of housekeeping things at the top of the show. You know, I've been looking at this impending election, and it is so difficult to resist making some kind of comment. So this is what I'm kind of thinking about. Next Thursday is the first debate among the Republican presidential candidates. I think it's on Fox. And I'm thinking what we might do on Friday morning, because our show begins at midnight on the West Coast, is that we might find someone who could kind of converse with us at a different level about the politics of what we're seeing in the mainstream. I'd like to bring a different set of perspectives to what is going on, because what is going on is kind of part of the mechanisms that I used to successfully predict that Barack Obama would become elected president and thereby won the bet at Coast and thereby got fired and thereby wound up over here, and you know, there's a kind of a causal chain. So I would like to grapple with this extraordinary thing we're seeing, and I'm groping for the right way to do it. I don't want to fall in the conventional left, right, Republicans, Democrats, whatever. I want to get kind of above that, as they said in the last cycle, the view from 30,000 feet. Except in this case, it may be a view from another dimension. So between now and next Thursday, which is what? We've got basically a week. Let me think of something I can do, people I can talk to. You might want to send me suggestions if you have anybody that you think would be up to that kind of a different perspective on politics, because I want to involve consciousness, I want to involve the changing physics, I want to involve the social trends that we're seeing globally. What I've called in some other venues the so-called Jim Carrey effect, and you can all think about what that means. So that's about a week from tonight, and let me just kind of poke around and see who I can come up with that will have that different kind of conversation, and hopefully lend some insights. I've got some people in mind. So if you have anyone, let me know and send me a note, and we'll see if we can bring them on. The other thing I wanted to remind everybody of is the archives. I'm getting a lot of email from people who are complaining that they're falling asleep and they can't hear the rest of the show. Now look, it's really very simple. You go to the othersideofmidnight.com page, you go to the right-hand side, you scroll down just a little bit, and you'll see two buttons there. One says listen, and the other says subscribe. Archive. You want to go to that one and you want to sign up and become a member, as Art says, a time traveler, and then you can listen to what we're doing any time of day or night on any device, any iPad, any iPhone, any smartphone, any computer, any tablet, anything. I mean, it is so possible now to take the quality that Art and Keith have been putting into this network and to listen anywhere on the planet. As I said to you a couple days ago, I have a friend of mine who was going to Machu Picchu, and that's one of the places that I wanted to take Robin and go measure the hyperdimensional torsion field aspects. And I'd like to do it in a way where we can actually do a show from there, or maybe a couple of shows, depending upon how long it takes for us to carry out the measurements. So my friend is going down, and I've asked him, I said, try to get hold of us on Skype to see if we can, get a signal, and if you can send a couple of images, because obviously, since this is radio with pictures, if we go and do this kind of thing, one of the things I'm thinking of is that we will document, we'll take images, we'll take pictures, we even can take video, and stick it on the web and stick it on Dark Matter, because remember, it's the Dark Matter digital network which allows us to do radio with pictures. And with that out of the way, I can't think of anything else that I probably should talk about this morning. why don't we get to our guest? I have a very interesting guy I want to talk to this morning. Frank Nizarzik, and I've mangled that terribly, Frank, so we'll get back to that in a moment. He's a professional electrical engineer. He graduated in 1975 with a BS in electrical engineering from the University of Pittsburgh. In 1987, he went on to obtain an AS in Business Administration from St. Francis College. He has studied physics at the Indiana University of Pennsylvania in the late 80s, and he's worked in industry for about 32 years. Frank has come up with some remarkable insights, not only into some cutting-edge physics, but the engineering that prompted the interest in the cutting-edge physics. And so without further ado, I would like to introduce everyone to Frank Nizarzik. Am I mangling that too badly?
Zendarzik.
Zendarzik.
Yes.
And I would love to be able to call you for the rest of the evening Frank.
That's good to go.
If you call me Richard.
Zendarzik is Sylvanian for tailor.
Ah, so it's a stitch in time.
It's like Snidar, and the Snidar is tailor in German.
Fascinating. So, Frank, how did you wind up looking at this exotic field of breakthrough propulsion and exotic energy technologies? What led you from I would imagine, a relatively mainstream academic perspective to, hanging out over the edge of the board and, occupying your time with the rest of us crazies who think there's something beyond mainstream physics?
Well, thank you for that question, Richard. And I've worked in the energy industry for the greatest part of my career, and I know that fossil fuels are finite. We're going to run out. I also realize that the environmental damage is done, and as the population of the Earth increases, we cannot continue to use these finite resources. We'll use them up and we'll cause a lot of damage. We need something new. We need new energy, and I began thinking...
But we need something sustainable, don't we?
Yes, we do. Yes, we do. And I began thinking out of the box on a lot of issues, and that's where I started, and I think a lot of things are happening. I visited national labs, I've spoke at conferences, I've met with some researchers, and things are just bubbling under the surface, but I think we're going to have some new energy and propulsion here shortly, and I think the future is quite bright. I'm very optimistic.
Well, it's interesting you should say that, because as an observer of this rather closely, I've noticed a number of NASA leaks over the last several months, probably 12, 18 months, something like that, particularly in this so-called breakthrough propulsion area, where there's a lot of press on the so-called M drive. We've talked about that on the show a bit. Why don't you kind of put that in perspective? What do you think of the technology and where it might go?
The M drive sort of caught me cold because it doesn't even fit into my theoretical construct. It's looks like a horn with microwaves in, and
a closed horn.
Yeah, a closed horn. Microwaves bounce back and forth, and
inside.
And there's this thing called the conservation of momentum. It's like a ball bouncing in there. Mm-hmm. The microwaves hit one side, push it one way, and bounce back and hit the other side and push it the other way. So there should be no net thrust.
According to conventional Maxwell equations, right?
Yes. And recently, Martin Timor, the European Space Agency, I had a pleasure to meet him in Washington at a conference. He's a very nice man. He does a lot of exotic research. Has tested one of these M drives, and he got a little bit of thrust. But it's a little fishy, because when he turned the microwaves off, there was still thrust. Mm-hmm. Should have stopped. No more
wait. Why would you automatically assume it would stop? If we're dealing with a physics which is the unknown, why would you think the laws of three-dimensional physics would apply to something as exotic as putting microwaves in a sealed container and watching it move across the room? Obviously, we're not looking at that, but...
Yeah, so I have a microwave right in my house. As soon as I push the stop button, it's off.
But that's because it's not configured to do something different.
I don't know what it's doing.
Well, the reason I raise this is because I've been following this whole M-Drive thing really closely, and I've been reading the reports from Roger Shire, who was the guy in England who 15 years ago, apparently an aerospace electrical engineer, similar background to yours,
Yes.
who noticed something very weird about microwave horns and antennas on spacecraft in Earth orbit. And according to his story, that's what got him on the trail that maybe putting microwaves in a sealed cone-like cavity, which had no exit, so you're injecting microwaves in there and there's no way they can supposedly get out, can generate a thrust. Now, that is so unbelievable because of the conservation of momentum and the conservation of energy, that why is it not possible that with that effect also comes a very delayed transient at startup and a delayed transient when you turn off the power? And the reason, again, I say this is because I know of other inventors who have invented technologies that appear to be loosely based on some of the same possible physics, and they all have this anomaly about them. And it's been well reported in the anomalistic literature that I've been reading that that's one of the hallmarks, that you're not dealing with conventional three-dimensional Maxwell stuff.
Well, it appears to be thermal. Something.
Well, that's one of the explanations. Is it could be thermal.
Maybe it's injecting some air out of the tube, and there's supposedly no air in the device. But if you ever see one of those little radiometers that spins in the sunlight, only a little bit of air produces the thrust to spin that. So we're talking micronewtons.
Mm-hmm.
And the verdict is out. And, of course...
so you're saying that the M-Drive, based on your theoretical approach to exotic propulsion, is not on your radar because it doesn't fit with the equations that you worked on?
No, it doesn't, but Podkletnov's device does.
Okay. Now, why don't you describe who Eugene Podkletnov is?
Well, he was a Russian scientist. He was over at the University of Tampere, and he was working on...
That's in what, Norway?
Norway. And he was making superconductive disks with layers. And he spun the disk really fast, and it was about a third of a meter, and he applied a 3 megahertz radio wave to it.
Okay, hang on. A superconducting disk is a disk made of what?
That's that ceramic superconductor.
And what is a superconductor?
A superconductor is an electrical conductor that conducts electricity without resistance at cold temperatures.
So the current will just flow and flow and flow forever.
Flow forever, okay. Yes. And so that's what they want to use them for. They use them in MRIs, for instance, to get a real strong magnetic field. Maglev trains also... we're going to use superconductors. The problem is they have to be kept very, very cold for a metallic superconductor to work. And they come up with these ceramic superconductors about 15, 20 years ago, but they're very brittle. And they never came up, and those can be cooled with liquid nitrogen, which are still cold, but it's a lot warmer. But they still haven't got a flexible, warmer operating superconductor that's reliable for general purpose. But I'm told it's just around the corner, that they're working on it. And
so that's basically a material science problem. So let's get back to Podkletnov. He has created a disk out of this ceramic, which conducts electricity. When you cool it down below liquid nitrogen temperatures, it goes superconducting, so the current flows forever in the disk. Now, with a flowing current, you should have a magnetic field, right?
Yes, you do.
So he uses the magnetic field to suspend the disk in its bath of liquid nitrogen over a magnet?
Yeah, and that's ordinary physics.
Okay, so the thing is hovering.
It's like a magnet train. It expels a magnetic field. It's completely impermeable to magnetic field, but it's completely permeable to the electric field. That's why the electric field flows without resistance, and it expels the magnetic field and pushes magnets up.
Okay, what was the anomaly that Podkletnov found?
Well, when he spun it, he got a gravitational anomaly. A friend came in smoking a pipe, and they noticed the smoke was rising in a column above the
how cool.
Device. Now, smoke is not magnetic.
No, but it's like a tracer. It's like a dye in a stream.
Yeah, so they went into the room above where the device was to make sure it wasn't
above the laboratory. They went upstairs,
and they blew smoke there, and they normally went right through the floor, so it wasn't an air current from the device. And
so the smoke in the room above the spinning ceramic superconducting disc was actually forming what, a vortex in midair in the room?
Yeah, it looked like I guess a little tornado, but it took the smoke.
Did anybody take pictures of this?
I don't really know. This was all reported in the Telegraph in Britain. I wasn't there.
Right.
And, quite a sensation. Boeing followed through, and NASA Marshall followed through. And I was down NASA Marshall.
You mean the Boeing airplane company?
Yes.
The big Boeing guys, the Boeing 747 folks. Okay.
And I went down to NASA Marshall, and they were doing these Podkletnov replications in the...
This is the NASA Center, which is in what, Huntsville?
Huntsville, yes.
Okay.
I met Whit Brantley there, and Lot, I believe Lot's his son. He's a movie producer now.
And what were they doing with this experiment, with Podkletnov's work?
They were trying to reproduce the effect.
Ah.
But they didn't follow through. They didn't know how to make the layered disc. They used a single layer disc, and they never applied the radio waves. There was the
radio waves?
Yes.
What radio waves?
Well,
I never heard about radio waves in discussion with this.
Yes, there is. There's a 3 megahertz radio wave applied to a 1/3 of a meter disc spinning really fast.
Okay, hang on. Describe the experimental setup.
Well, they didn't have the radio waves. Podkletnov applied the radio waves.
So it's the NASA folks. But let's get back to Podkletnov. So he's got a disc spinning, cool with liquid nitrogen.
Yes.
It's hovering above a magnet because of the repulsion effect of the magnetic field.
It's all normal.
And he's measuring a change in the gravity because he notices the smoke from his friend pipe as it drifts across the spinning disc assumes some kind of strange columnar geometry above the disc.
Yes.
Right?
Yes.
But he's doing something else besides just spinning the disc in his lab. You say he's bathing it or pumping in or transmitting with an antenna a electromagnetic radio wave, right?
Yes. Yes, you have to do all of that to make it work.
And where was the radio wave being pointed?
Right at the disc.
So he's got what, kind of a feed horn?
Yeah, it's right at the disc. 3 megahertz. We're on AM radio. That's about 1 megahertz. 3 megahertz is in the lower end of the shortwave band. A little higher than AM radio.
Would that be UHF television?
No. It's just radio, a little higher in spectrum than the AM radio.
Okay.
So low frequency. In today's terminology, would be low frequency radio.
I was going to say it changes with time. All right.
Yes.
So 3 megahertz. How powerful?
Well, I don't know that.
Okay. I mean, was it just a very small signal, or was it like?
Oh, I think it was large enough.
Microwave power.
Stimulate the disc.
Like a kilowatt or something?
Yes.
Okay. So all right, now here's the big question. You went down and you obviously somehow got yourself inside at the NASA Marshall Center where they're trying to replicate Podkletnov, right?
Yes.
We might divert and ask you how you did that, but let's hold that for a second because I want to know why, if they're going to duplicate another scientist's work, why didn't they duplicate all of it?
Well, there was a scientist down there, Ning Li, and she had her own ideas, and she wanted to spin the nucleons up to make a gravitomagnetic field. Mm-hmm. She was following her own hunches and leads and not exactly replicating the experiment.
See, now this is the second time I've heard of NASA apparently attempting to replicate some astounding invention from somewhere else, but they don't really replicate it. They kind of take off on their own gadget, and they don't. This is not replication. This is actually false advertising.
It wasn't replication, and they were also...
I'm glad you agree.
Their budget was cut because the experiment did not fit into the theoretical constructs.
Well, back up. Run that by me again.
There was a lot of the established scientific community felt that NASA was taking money away from very good programs like hot fusion and using it to fund this Podkletnov replication, which they felt had no possibility of working.
Yeah, but
the budget was cut on. They had a very small budget.
But it's peanuts. I used to say, it's like coffee money at headquarters for a week.
Yes.
It's not real money. I mean, unless you got up in billions, it's not real money. So obviously that was an excuse. So was someone in NASA trying to shut down a promising line of research because it might prove positive?
A lot of people outside of NASA that were within the established scientific community were saying bad things about this program. They felt it was a waste of taxpayer money.
Okay. All right, then let's go to the diversion. How were you able to get kind of cozy on the inside and find out some of this inside stuff?
Well, I've published peer-reviewed scientific papers. I've been out there. People read my papers, and I was well known enough to get in the door and to take a look.
Okay.
That's where I found out. But I observed something there that nobody else saw, and that was from the experimental parameters from Podkletnov. Mm-hmm. The 3 megahertz signal on a third of a meter disk. If you multiply the frequency times the diameter of the disk, that's frequency times wavelength, mm-hmm. you get a velocity of 1 million meters per second. And I felt that was important at the time.
Wait. Run this by us again slowly.
Okay.
You take the size of the disk. He was working with, what, a 3-meter disk?
1/3 of a meter.
Oh, 1/3 of a meter, which is roughly how many inches?
A foot.
About a foot, okay.
Yeah. And
he's spinning it. How fast is he spinning it?
Oh, really fast. I don't know.
Thousands of RPM?
Thousands.
Yeah, that's what I remember in the literature, thousands.
Then he's hitting it with a radio wave of 3 megahertz.
3 million cycles per second, and the disk is spinning.
So
is the spinning correlated with the frequency of the radio wave? In other words, is there some resonance that he's looking?
Well, he said there was, but it wasn't really defined.
Okay.
But 3 megahertz times 1/3 of a meter is 1 million meters per second. And I did that multiplication.
But why would you think that? I mean, I don't understand logically why that multiplying those two numbers gives you any real physical parameter.
Gives you a velocity.
Yeah, but a velocity of what?
1 million meters per second. That's what I didn't know.
No, wait. You're still, look, you have a disk. It's about a foot across. It's spinning. Yes. It's spinning thousands of revolutions per minute.
Yes.
You hit it with a radio wave.
Yes.
Why is the size of the disk multiplied by the frequency or the wavelength of the radio wave important at all?
That's where I started, and I found out really amazing things about that.
So this was just an out-of-the-ether, aha, what if I do this?
Yeah, that
and then you got this number, and that led you to?
That led me to a classical interpretation of quantum physics. It actually revealed things. See, the disk itself is a macroscopic quantum object. It's not a real one. It's not a real small thing, but it's a Bose condensate, and that's a macroscopic quantum object. And when you put the radio waves in, you're vibrating it, and that is a macroscopic quantum object.
So you are resonating it at a particular frequency.
It's in a state of quantum transition.
And the rotation has to be part of that equation.
Yes.
The rate at which it's because the rotation gives you an angular momentum number.
Yes. But what I found out, now I got the spacing of the nucleons in the atoms. And a nucleus is sort of like a liquid drop. It's sort of like has a constant density like water.
That's one of the models, yes.
And the submarine, for instance, will send a ping out, and it has a high velocity in the water, and the velocity is pretty constant in the water. And I got the nucleon spacing, which is 1.35 fermimeters. That's the Fermi. And I put it into a calculation, and I got the velocity of sound in the nucleus. And nobody's ever really worried about that, but it was 1 million meters per second. And so the velocity of sound in the nucleus is the same as the velocity that was imposed onto Podkletnov's disk.
Now, when you say sound in the nucleus, are you talking just ordinary acoustic?
No, it's a real high. It's a real high frequency sound. It's beyond our range.
No, but I'm saying, is it a literal physical
shaking.
wave.
Yes.
Or is it an EM? Is it an electromagnetic wave?
It's a longitudinal mechanical wave. That's
a mechanical, longitudinal, physical compression wave.
And that's my number. That's what I got. It's 1.094 million meters per second. I back calculated, and that's the velocity of sound in the nucleus.
So it sounds to me like Podkletnov may suspect this, and that's why he made the numbers all fit.
Yeah, I don't know. But
how else would you explain that amazing coincidence?
Well, here's what really happened, and this is in my peer-reviewed paper. I set the velocity of sound in the nucleus equal to the velocity of light in the atom. And it's a little bit of calculation that I did. And out of the calculation, I've got all of the energy levels of the hydrogen atom and all the other atoms. So I was able to produce quantum calculations without Planck's constant by taking the velocity that I've observed in Podkletnov's experiment and doing some math on it. So that's where my work is, and that was published in peer review.
Do you have a link on our Other Side of Midnight webpage tonight for that paper?
I have several links, and that was the Bentham Science Journal. I just had that published in last November.
Okay.
It's out of Saudi Arabia. They published it.
So what does this imply? What this coincidence of numbers? What's it trying to tell us?
Well, we have to go somewhere else. We have to go look at cold fusion, and I also visited there, and that was sort of unique. And I went to PowerGen 95 to see
That's
James
a conference,
Patterson.
right?
Yes, to see James Patterson and his
James Patterson. Patterson is the guy, correct me if I'm wrong, but he's the guy that on Good Morning America live did a demo for the same science guy that interviewed me there many years ago. I can't remember his name, Michael something or other. Anyway,
McCurdy.
He blew Michael's mind by showing him in 20 minutes dramatic reduction of radioactive time constants.
Yes,
the radioactive decay of a sample of uranium with a half-life of 4.5 billion years. He was able to, with the Good Morning America cameras rolling, he was able to reduce the radioactivity by about half in 20 minutes.
Yes.
And blew the science guy's mind, blew my friend Gene Mailov's minds, because you obviously, if you wrote for Infinite Energy, you knew who Gene is.
Gene Malov, yes, I
know.
Yeah,
we'll get to Gene in a short while. The point is, this was a demonstration on national network television showing that you could take theoretically, you could take all of the radioactive store supplies from every reactor we have powered up since World War II that's now sitting in various places, Hanford and, down here at Yucca Mountain and other places, disturbing the political body politic enormously because no one can think of a safe way to store it or get rid of it. If you created a device, a technology based on what Patterson demonstrated that morning, you could just feed the radioactive material through the plant, and it enters incredibly radioactive at one end, and 20 minutes later it leaves with almost no radioactivity.
Yes, that's coming. That technology is coming. Not from Patterson, because he's deceased now, but other inventors are following through.
So Patterson observed this as a side effect of his primary invention, his primary gadget.
Yes.
Why don't you tell us what he was trying to do, and this whole radioactive thing kind of just appeared serendipitously?
I'll tell you about the amazing thing that I observed.
Okay.
Yeah, it needed a preheater to get it working, and preheaters...
Well, describe what he was doing.
Well, he had a cell, and he heated the water up, measured the temperature and the flow, and then measured the temperature and flow out of the cell. This was at the SETI demo, and it was 1 kilowatt. It was a lot of power, of excess power. But my question was, what in the world could a low-grade thermal energy have to do with a nuclear reaction? The energy was of a nuclear scale because it was a lot of energy for just a little bit of material.
Well, let me pause you there because we're going to tease everybody. On the other side of the break, we'll pick up this story when we come back to the other side of midnight. And we are back. My guest tonight is Frank Snyder. We're discussing actually his that is his Skype name. His real name is Indarsic. I'm still mangling.
That's fine.
I can see why you wrote Frank Snyder on Skype. So
I do that because I try to keep a little under the radar. Initially, when the internet came out, I used my real name, and I'm finding that sort of a mistake because there's a lot of people out there that are looking for ways into your business.
Well, as I've said many times, the internet has given voices to people who should never have voices.
Yes.
Okay, so you were going to tell us some stuff on the inside that you'd observed that is kind of relevant to the bigger picture of why Podkletnov has gone nowhere. No one has apparently replicated a very interesting so-called anti-gravity experiment. Because
I want to go back to Patterson,
okay,
if I may. And he had a preheater required to get it working, and that's heat is a thermal vibration. And it's in the warm, and that's in terahertz. It's about 10 to the 12 hertz. And his particle size, his grain size, turned out to be critical, and that was the size of the grains in the cell, 50 nanometers. So I multiplied again, this time terahertz times 50 nanometers, and I got 1 million meters per second. The same velocity that I observed in Podkletnov's cell, I have observed in Patterson's cold fusion cell, which are dramatically different technologies.
Oh, totally. There should be no relation at all.
And what I began to believe is that there isn't a million new things to find out in physics. Physics is mostly understood, but the cold fusion cell is just another aspect of the Podkletnov device, a different mode of operation. And it's the same phenomenon emerging under a different set of conditions. And what that phenomena is doing is modifying the range and the strength of the magnetic components of the electromagnetic field, the gravitomagnetic field, and of the nuclear magnetic field, which is called the spin-orbit force. And so these magnetic components, if we can modify them, we can control them. And these technologies are leading us in a direction where we may be able to control all the natural forces.
Well, if you can control the ether, if you can control the matrix in which these things are actually formed, atoms and other subatomic particles, then you're on the road to controlling everything.
Well, let me give you a little history here. If you rub a balloon on your head and you stick it to the wall, that's the electrostatic force, and it gives a nice demonstration, but it's really not usable for much. If that's all that we had, we wouldn't be very far other than some exotic demonstrations, maybe your hair standing up. And that force is conserved, which means there's only so much of it. It's sort of like money. You only have so much money in your wallet, and there's only so much time in the day. But then Nikola Tesla, he started fooling around with the magnetic force, and so did Maxwell and a lot of other people. And when you move the electric force, you get the electromagnet. You get the magnetic component, and that is one of the few things in the universe that's not conserved. That's really amazing. A lot of people don't realize it, but if you put a wire, it has a very weak magnetic field, but you put an iron core around it, you get 10,000 times the magnetic field. The iron core amplifies the magnetic effect. It would be sort of like if you had $1 in your pocket and you put an iron core next to your wallet, now you had $50,000.
Well, isn't that because the current in the wire is aligning the nuclei so that the magnetic fields of all the atoms, or a lot of them, are all kind of aligned?
But there's also a mutual effect that's an additional force.
And that's where the amplification is coming from.
Yes. Well, the magnetic component of the electromagnetic field is not conserved. It can get greater. And so why not? Why cannot the magnetic component of the gravitational field be amplified? Is there a soft iron equivalent for the gravitomagnetic field? Can we amplify that? It's always assumed to be fixed, but we can see from the electromagnetic example that we can increase the strength of the electromagnetic field, so the gravitational field should follow the same rules. And the gravitomagnetic field is very weak. It's 10 to the 39th power less than the electromagnetic field. It's usable for nothing. We can barely detect it. But mainstream science never looks at changing the strength of the gravitomagnetic field.
Well, wait. You're saying mainstream science, but mainstream science is divided into two tiers. There's the black ops crowd. They're doing all kinds of amazingly cool things. And then there's what the rest of us have to kind of live with, that produces, CD players and TV and smartphones. But that's the limit to which we're supposed to think of electromagnetic phenomenon, which in fact in the black ops crowd are doing these stunning, astonishing, interacting with the ether and replicating matter and energy and beams and tractor beams and pressor beams and all kinds of exotic things out of sci-fi that we're not supposed to know exist.
Yes.
And Podkletnov stumbled with his experiment between the black world and the white world, and as I asked you at the top of the segment, why hasn't anybody actually moved forward with what Podkletnov gave us, what he demonstrated?
Because it doesn't fit into their theoretical constructs.
That's their excuse, but what's their real reason?
Everybody's in it for money. There's no money, they're not doing it.
Well, why wouldn't there be money? If you can control a gravitational field and produce the equivalent of a gravity sled like in Star Wars, you can, as I said the other night, you can take and revolutionize the transportation business of things, of stuff. That's basically what we are doing. We are shipping huge megatonnage of stuff from point A to point B.
Oh, yeah.
And we're spending a huge amount of energy in doing that. If you could do it on an equipotential surface, meaning a gravity drive or a gravity sled or a gravity negator or whatever you want to call it, you could revolutionize just the energy costs of transportation alone.
We're going to the stars if we can do that.
But why would you say there's no money in it? The money cannot be the reason for suppressing this technology.
I don't think a lot of people know about these technologies and what has happened.
Yeah, but those that do are trying to make them work, and they never appear. It's like last night I had the conversation with someone who's an expert in the so-called free energy area, and I kept asking, why can't we go to Kmart and buy this stuff, wholesale?
Well, it's coming. It's coming. The M-Drive, I don't know, it seems to be doing some results, and there's this various groups working on cold fusion, and it appears to be emerging.
Okay. Now, you're saying that you believe these phenomenologies are all kind of underneath related?
Related, yes. Now, I want to go back to the balloon.
Okay.
And that's the static electrical force, and the nucleus has a static force to it, and it repels the nucleons, and in order to get them to stick, you have to overcome that repulsion, which requires very high temperatures, like the inside of a nuclear bomb, and in very exotic conditions. And there's no way.
This is cold fusion, and you're banging nuclei together, and they're.
No, this is hot fusion.
That's what I mean. It's cold fusion.
Yeah, hot fusion requires hot temperatures, but you only consider the nuclear static force. It's like electrical technology, and the only thing you did was rub your head on the balloon and stuck it on the wall. You never considered the magnet. But there is a magnetic component of the strong nuclear force. It's not electromagnetic, but it has the same structure. It comes out of the North Pole and South Pole. And that's another force that they don't consider. And that force is not conserved. And these experiments now, these cold fusion reaction is proceeding not by conventional means, but by the nuclear magnetic force. And it's exciting new field that I don't think really a lot of people understand. But I think it's emerging with the gravitomagnetic force in Podkletnov's device and the strong nuclear magnetic force. And what is doing it in both cases is a vibrating Bose condensate, a vibrating superconductor. And so soft iron increases the magnetic field for the electrical field, but a vibrating Bose condensate increases the magnetic component of the gravitational field, and a vibrating Bose condensate in the cold fusion increases the magnetic component of the strong nuclear force.
Okay, let me stop you there.
It's really amazing stuff.
Well, because you said something really interesting. There are two other experimental setups I'm aware. Mm-hmm. One is the work of Maurice Allais, who is the Nobel laureate. He won the Nobel Prize in physics in '88, but he really was a physicist. His mommy told him to go into something where he could make money, but his heart was in physics. So He's published all these papers in the French Academy of Sciences over decades and decades. He died a couple of years ago in his late 90s. But in 1954, with a pendulum setup, Allais in France, in a laboratory under Paris, was observing the motions of what we called a paraconical pendulum, to be differentiated from a so-called Foucault pendulum, which is the big ones you can see in a museum when you go into museums with kids and all that. You see this big pendulum, which is marking out the rotation of the Earth. Well, his paraconical pendulum was much tinier and had a much higher period, obviously, and he would manually reset it about every 20 minutes, and he was doing this for days and days and days and days on end to try to get what he called a chained series of measurements of the motion of the pendulum in space, and he discovered through this work in the 50s and into the 60s, published again in peer review in the annals of the French Academy of Sciences, that there seemed to be some kind of structure or orientation or matrix alignment in space-time.
The ether.
And exactly, he's measuring this aspect of the ether, and then when he did it inadvertently, because he's buried underground in a laboratory which has no windows, right? So he's doing these experiments, and suddenly his pendulum goes nuts. It reverses, it changes period, it backstops, it then reverses back again, and it's only later that you looking at the data, he calls out to some friend of his, and his friend says, well, didn't you know, Maurice, that there was just a total solar eclipse that passed over Paris?
Oh.
So he found this astonishing change in the dynamics of pendulum motion during an eclipse. Now we fast forward the film.
For that.
All right, we fast forward the film, and he measured a second eclipse in '59 at two locations separated by I forget how many miles, and he got duplicate data. And I've actually published on the EnterpriseMission.com website this data in several papers. Well, the next step is to figure out what could be grabbing the pendulum out of space-time, out of the ether, and during eclipses, during the alignment of the Earth, Sun, and Moon, causing exotic, bizarre, these were in excess of 1 million times of what you would calculate from any relativity applications to the motion of the pendulum.
Well, if it affected that much, it should have caused an earthquake, tidal waves.
Well, but hang on. The key part of Allais' work was it only worked in a dynamical system. The pendulum had to be moving. The anomalies are only measurable with a dynamic sensor as opposed to a static sensor. So years later, when other scientists tried to duplicate Allais' measurements, they used a static gravimeter, and they got nothing. Yeah. And in '99, when the big eclipse crossed Europe, and NASA actually, a scientist at Marshall named Noel Ninevers, I think, set up to kind of coordinate a global effort to look at the Allais effect during the eclipse in '99. The memo, and I've got a copy of it, that Allais wrote to NASA describing again how to replicate his experiment, was woefully ignored again by the NASA scientist who was supposed to be duplicating and replicating Allais' work.
Well, they see it through their lens.
Every time. But no, Frank, I think you're being a little bit too charitable. I see this as a conscientious, as I said last night, I see this as a conscientious political effort to appear to be replicating this avant-garde work, but in fact they leave out missing pieces so they don't replicate it, so they can say, see, it doesn't work.
Why would they do that?
To keep it suppressed. They don't want to develop a real space drive. That's my point. These weird things keep... What? You don't think that?
Most people I know want to develop. I'm trying to write Android apps. I want to develop them, and I'm working real hard.
Yeah, but you're by yourself.
People want new ideas.
You're like Enterprise. The Enterprise mission, I run the Enterprise mission. I'm accountable to nobody. Mm-hmm. You know, we accept money from people, but we tell them, you know, you don't get to tell us what to do with it because we know what we're doing, and if you want to support us, fine, support us. If you don't, that's fine. That's a free will choice. You're in the same boat. You're funding your own work. Yes. An institution like NASA, which is responsible to everything in the political structure that we know and suspect it's responsible to things in the political structure that we don't know, if they're told quietly, you will deep six this, you will get rid of this evidence, you will make it appear it doesn't work, that's what they appear to be doing.
I don't know what's going on in them black programs, but
see, the Ning Li effort to replicate Podkletnov was not black, it simply was bungled. And the excuse is, yes, she had her own ideas. Why, if you're going to duplicate somebody who's discovered something amazing, would you try to intrude with your own ideas when they've already done something that works? Wouldn't you try to figure out how they got it to work?
Sometimes that's the first step.
Well, it should be the first step.
Replication is especially something that's out there.
But see, in science, here's another thing. There's no real glory in replicating somebody else's work. Now, that's not totally true. Like Eddington got a huge boost from validating with his eclipse measurements Einstein's predictions. And so Eddington became almost as famous as Einstein back in the 20s when this was going on. But most of the time, the guys who replicate what a pioneer has discovered, they don't seem to get the glory, and there is this disincentive to replicate somebody else's stuff as opposed to doing your own thing.
Yes, it's fun to initiate structure, not to follow the procedure.
But an institution which is responsible to American taxpayers should be in the business of replicating stunning things that could benefit the national, whatever you want to call this national experiment we're all embarked on. And they shouldn't allow individual scientists to supersede with their own agendas what needs to be for the common good verified before you go off on tangents.
Well, it's not over.
So where are we? Where are we with this work?
And Andrea Rossi, he's an inventor.
Okay, now we're talking about the ECAT system.
Yeah, he's followed through on Patterson's work, and these ideas are moving forward, and they're getting more results. They're learning how to do things better.
So why don't you describe what? Why don't you describe?
Mainstream science is going to have to accept that these things are real, and then when that happens, then the money will flow.
But you say that, and it's like, okay, where is it? I mean, Gene and I had these same conversations, Gene Mailoff, 20 years ago. And tonight, most people on this planet think cold fusion is a hoax. They think breakthrough propulsion is a fantasy. They think anything other than rockets and Newton, it belongs on the backs of cereal boxes. Yes. We have not moved forward politically in this arena for the last 50 years. I remember when Bertel and I did that special covering the flyby of Mariner 4 of Mars 50 years ago this past July. We were looking forward to things like controlled anti-gravity and things to supersede rockets. And a half century later, we're still building the biggest damn rocket on the planet. That's what NASA's doing with the so-called SLS system.
And so heavy, don't lift off.
and the really exciting stuff, the EagleWorks stuff with the M drive, the few people that were actually talking in forums and spreading information on the web about the experiments, after the last spate of publicity from the mainstream media, the NASA people running the EagleWorks show, giving them the money, told them under no circumstances can you talk to anybody in the press, because I've tried to get these guys.
That'll kill reputations.
Yeah, but again, it's a wonderful way to manipulate the conversation so ultimately we never see anything.
Yes.
And you're saying that assessment is about to change.
I think so.
And that's based
three
on
things happening now. The gravitomagnetic experiments are producing results. And there's several groups in the cold fusion area. That'd be George Miley. He's a friend of mine. He has his lattice energy, and Mike McCurby, which I don't know him very well. He's there, and Andrea Rossi are all producing results.
Miley's not the blacklight power guy, is he?
No. The blacklight power guy is pretty much on his own with these shrunken atoms, and that doesn't fit into Miley's University of Illinois. I met him at the Power Gen demo. He's one of the top nuclear scientists in the country, and he's was tenured, so he was able to follow through, and he did the analysis of the nuclear products in Patterson cell. I was there at Wright-Patterson when he announced it. And the mainstream science said it was contamination. Other elements were just leaking in because it's a very small film. But Miley said that there was elements in there with abnormal isotopic concentrations. Too many neutrons or not enough neutrons.
So
and
we're
these
talking
don't exist in nature.
So you're saying you never described the Patterson cell. Why did you do that?
Say again?
Describe the Patterson cell before we get to the anomalies.
Okay, well, it was a thin film, 50 microns thick of like tinfoil on top of a bead. And then there was an electrolysis cell, and the electrical current drove hydrogen into the bead, and that started the reaction. But because the film was...
So hang on. You got basic, let's say, let me kind of paint the picture here. This is supposed to be radio with pictures. You got a glass jar. You have filled it with little tiny plastic beads that measure what? A few hundredths of an inch across?
And they were sputtered.
And each one is covered in a vacuum. They're prepared in a vacuum with a spritz of metal that sticks to the outside like a coating on the bead.
Yeah, very thin.
And it's very thin. And what's the composition of the coating?
Well, Patterson used the layers of copper and palladium.
Okay. And then he puts, thousands, tens of thousands of these in a glass jar?
Well, maybe 100. And then he put an electrical current that drove hydrogen from the water into them, and that's what produced the energy.
So, wait, he's immersing the beads in water, right?
Yes.
And then he's putting a current across the beads.
Yes, so that was the cathode, and the hydrogen, when the water splits when you put a current
right.
And the cathode attracts the hydrogen, and the hydrogen from the water was going into the beads.
But he got an anomalous amount of heat out of the beads, more than if you tallied up what was being put into the current.
Yes, 1 kilowatt more.
Right. Now, in addition to the heat, he also got these weird radioactive decay acceleration effects where he could accelerate the decay curve of uranium from 4.5 billion years to 20 minutes.
Yes, and he also got elements on the beads when they were analyzed that
different transmutation of elements on the surface of those coatings on the beads when they took them out and
but they don't exist in nature, so they had to come from a nuclear transmutation.
Well, that kind of marries with the effect on the
so that wasn't contamination.
Uranium.
It was made. So there's a lot of evidence pointing to there's really something going on here.
So when you put current through his beads coated with a particular metallic multiple layer film, and you put it in water and you subject it to a current, you say roughly a kilowatt.
Energy came out.
And weird space-time effects that change the elemental structure of contaminants on the beads,
structure.
As well as the radioactive decay rate of radioactive materials that were just nearby and exposed to a field that this set up.
That happened, but that's impossible. So,
well, under normal physics, that's impossible.
It's impossible if you only consider the strong nuclear force, the static component. If you don't consider, but if you start throwing the magnetic component and realize the magnetic component is mutable, do the same thing with nuclear power that you did with electrical power.
So you're looking at a dynamic versus a static system, just like L.A. said.
It's a dynamic system.
Yes. Now let me leap across the pond to England, because Roger Shire, who is the guy behind the M Drive, the aerospace guy with similar background to you, I'm going to get Roger on the show because I can't wait to ask him some really leading questions.
Yes.
But here's what struck me. He has been saying for months and months and months now that unless you introduce another motion, another force, another vibration to his EM drive engine, it doesn't work. And no one can figure out why you should have to do that, but that's the dichotomy between a dynamic system and a static system, and the dynamic system seems to somehow hook into the ether, maybe through the Bose-Einstein constant mechanism.
Yes.
In other words, you seem to be on to a physics underneath that can explain, or at least begin to explain, these disparate phenomenon that all apparently have the same cause, the same root,
yes.
the same mechanism.
Underlying cause is that velocity, 1 million meters per second. And when in my peer-reviewed papers, and I also have a book, Energy, Cold Fusion and Anti-Gravity at Amazon, I do these calculations. I was able to produce all the energy levels of the atoms, the intensity of spectral emission, a lot of things that are very common to physics. But I didn't use Planck's constant. I used this velocity that was observed. And that's a magic number, I think. I think I'm onto something.
Well, it appears to me, if you're identifying the same number, plus or minus, give or take, because there are error bars, right?
Yes.
In these disparate setups, these disparate rigs, these disparate experiments, and in these disparate phenomena,
yes,
then it looks like you have figured out some resonant mechanism that's coded in the visible outcomes of these very different experimental setups.
Well, I didn't know what that was until I was talking with the alien scientists, and then throughout discussion,
you were talking with whom?
Jeremy Rye.
Okay.
And that is the velocity of sound in the nucleus. That
Holy cow.
So things are starting to gel out.
Hold that thought. We will be back momentarily. We will see you on the other side of this break at the top of the hour. And we are back. You are listening to The Other Side of Midnight. My guest is Frank Zdarczyk, and we are discussing free energy, breakthrough propulsion, strange subterranean or hidden, activities at the space agency at NASA. Frank, you keep telling me that you're expecting these breakthroughs are going to happen soon. What's the actual evidence that we're not going to continue with the status quo of the last 50 years?
Well, the cold fusion phenomenon is really leading the way with inventors like Andrea Rossi, Mike McCubry, George Miley. They've all gotten results. Mike's got results where he's produced tritium, which is a radioactive element that decays in nature and can only be produced by a nuclear reaction coming out of these cold fusion cells. So
it has. I think it has a half-life of 12 years or something. Tritium has a half-life of 12 years.
Yeah, it wouldn't be around.
It's like the methane on Mars. I said it's like the methane on Mars. It shouldn't be there, and yet
shouldn't be there. And so we're getting tritium, which is detectable.
All right. So which one of these devices is poised on the edge of commercial production?
I think Andrea Rossi is. He's got funding.
This is the ECAT.
The ECAT, yes. He's got some investors.
Why don't you describe both how the ECAT looks and works, and why you think it's on the front of the runway?
Okay. What's different about the ECAT is Patterson loaded hydrogen into his metals with a electrolytic cell by splitting water. The newer technique is you just pump hydrogen in. You get a bottle of hydrogen and you put it into the cells. Now, because there's no water in these cells, they can run hotter. And that increases this vibration, this the amplitude of it. And what Patterson found in his cell, there was a positive thermal coefficient. So the hotter it worked, the better it worked. It's like a fire. the hotter it is, the more it burns.
You mean like
And
the thermal
Patterson-
thermal efficiency?
Well, I don't know if it's efficiency, but the process. And the newer devices are running close to 1,000 degrees.
Oh my gosh!
Then they also add a little bit of lithium in, which is, I don't know what that does, and it seems to be more reliable and producing energy more efficiently.
This is the
Most recently,
ECAT.
they're finding some commercial catalysts that are working just as well as anything. They have a catalyst that they use to split natural gas to make plastic, and they're finding that works out of the box too. So a lot is going on in a lot of different areas, and I can't see how it cannot go on this fringe before it really breaks through. But
what is Rossi's commercialization plan? How is he planning to take this to the market, to customers?
Well, he's made a 1 megawatt plant that produces electricity, but it's sort of under the water, and he's keeping things quiet because he doesn't want people to steal his technology.
Yeah, we actually talked about this last night.
Reputation too. He had some problems in the past, so people always go back and say, "Look what he did in the past. He did some things wrong." But I don't think that distracts from the credibility. His device was recently replicated in Russia. There was another guy in Poland that ran some experiments that got the same results. There's a group in Sweden that independently tested Rossi's device, and they said yes, it was producing anomalous energy. So there's something going on there, and it's moving more and more into the mainstream very slowly.
Well, are there any demos of technology that would fit, like, in your basement? I mean, a megawatt is a little more than I need here right now.
Yeah, I know. I think that's his mistake. He needs to make something, if you want to have a match.
Well, it looks like he's catering to the big industrial, centralized power folks like, Con Edison or somebody.
I don't know.
Well, one megawatt is industrial level power. So he's looking to make a lot of money off the current infrastructure of centralized power, whereas all of the free energy folks that I know, and I hate that term, by the way, free energy is such a misnomer. Mm. But anyway, what we would like to have is something that would be, between maybe 5 and 15 kilowatts that would sit in your basement, that would quietly be there by the water heater, that would hum gently, yes. That you could come down and pat it and tell it what a good job it's doing. And you don't have to worry about it. It just sits there until maybe you have to recharge it in a couple of years with a new load of water.
I don't know why he's doing what he's doing.
Well, it looks like money. There's a lot more money in megawatt units than there is in thousands of individual consumer units, wouldn't you say?
Well, consumer units are a problem because if you say it's a nuclear device, they'll immediately regulate it and won't allow any of them to go out. So he's got to be careful what he says. He has to say it's...
Why would he even bring... See, it was Pons and Fleischmann that kind of got us, I think, in this wrong end of the telescope, because they termed what they were doing cold fusion. But it's not fusion. It's something so much more interesting.
Yes.
And what do you think it is?
I think it's just like iron increases the strength of the magnetic field. This bead is also a superconductor. We found out, the guy named Sonati found out it's a superconductor.
Wait. You mean Patterson's beads were superconductors?
Yes.
Really?
They were like little Podkletnov discs.
At what temperature?
Running at a different frequency.
At what temperature?
At what temperature? They're running at terahertz, 10 to the 12 hertz. That's
what temperature? Not what frequency of the infrared. What temperature were the beads running at?
Oh, they run at a little less than boiling water,
And they were superconducting at those temperatures?
Yeah, over small domain lengths, 50 nanometers.
So we're talking micro, but that's where the processes go on, so that's what counts.
Yes.
Now who was the guy who measured that there? I mean, this is breakthrough. Look, if you have superconductivity even over nanometers at boiling water temperatures, that's a breakthrough.
Yeah, Sonati did it. He had a wire. And
now, who is he?
Resistance. An Italian researcher.
Okay, when did he publish?
Yes, it was published.
When?
I don't remember the date, but it's probably 1998, around there, long time ago.
It's that old?
That old, yeah.
See, I follow this pretty closely, and I never heard that Patterson's beads were superconducting at his operating temperatures.
Yes, well, they knew that palladium hydride was a superconductor since the 70s. But it's superconductive over very small lengths. You can't make a wire out of it. It's just little.
Yeah, but if you're looking to create a reaction and the beads are cozying up to each other, and what you're worried about is the electrons crossing between beads in those shells, why do you care that it's not useful for carrying current in a wire? If it makes the effect work, if it's part of the effect, isn't that what you should be looking at?
Yes, the superconductor is a Bose condensate, and what's common to all these systems is superconductivity, which is a Bose condensate, and vibration.
Hang on. You've been talking about the Bose condensate for a while tonight. Why don't you define for folks what a Bose condensate is?
A Bose condensate is what's in a superconductor. A superconductor conducts electricity, and
that's
scientific
sounding
word.
a bit. That's kind of circular to me.
Well, they're for our purposes, the superconductor has a Bose condensate inside of it.
Well, hang on. Let me try it this way.
It's a condensate of electrons.
If you look at atoms in an experiment, cool a bunch of atoms in a chamber down really, really, really cold, they find that they can get all the atoms to have the same state.
Yes.
The same quantum state.
Yes.
So they become, in essence, one superatom, even though they're composed of a lot of little atoms.
It's a macroscopic quantum particle.
What you're saying is that the superconducting properties of the spinning ceramic disk in Podkletnov's experiments act like it's one humongous big single atom.
Right.
Okay.
You've got it.
That's
now,
what we...
If you vibrate it, guess what it is? It's a single atom in a state of transition.
Because it's connecting to the torsion field, which is vibrating, which is why you've got a vibrator detector to hook into the field. This, by the way, goes together with our measurements. Because we're
vibrating superconductors, and they're putting it in a state of transition because it's vibrating, it's moving.
Now, Shire, this is the guy in England, the aerospace guy with your kind of background, who invented the EM drive 15 years ago based on observations, he says, of satellites and their microwave feed horns and all that in zero gravity. He's planning for his next demo engine, his EM drive engine, to make it superconducting.
Yeah, that'll increase the Q.
That's what he says, yes. But if you're saying that a superconductor that's vibrating as a Bose condensate is more susceptible to the ether interaction?
No, I'm saying it acts like soft iron, but for the other.
It will concentrate a field. It will amplify.
Magnetic component. Yes.
Okay, but that somewhere in that appears to be the key to making this not only work as a space drive, but also work as an infinite energy source.
Yes.
So all right, your assessment is we're on the threshold of public breakthroughs, acknowledgement by real mainstream institutions like MIT or Caltech or the RAND Corporation or Bell Telephone, that this stuff exists, it works, and we can create technologies and gadgets and devices out of it to make life a lot better for a lot of people on the planet. You're saying that's coming.
That's coming, and when you really understand what's coming, for instance, we're talking and people are picking up this signal because we can control the electromagnetic force. All of our technology is based on the electromagnetic force.
Yep. We
are learning how to control the other forces, and the technologies that will emerge out of this will be so amazing. We're not at the end of technology. We're at the beginning.
No, we're just at the beginning. I mean, these are the technologies that are at the heart of what I have described in our work in assessing the ruins we found all over the solar system on NASA data and other data as the remnants of a Type 2 super civilization. What you're describing, Frank, is the technologies that would be at the base, that would be the foundation of such a Type 2 civilization.
Yes.
But you're not talking about them in 10,000 years or 100,000 years. You're talking about these things could come to a head in the next few years.
Yes, it's really sad that wars have to come for countries to move ahead and invest money in new technologies. But this thing's coming, and I hope it reaches a point where the mainstream scientific community realizes there's something real going on here and takes a look at it. And I am so optimistic that the technologies that will emerge from this are actually going to change the type of our civilization. It'll take us off this planet to Mars. If we can get 1G acceleration for 1 year, we're going to the nearby stars. I want to see this in my lifetime, and I've been pushing, but it's been very difficult.
So, I mean, I'm just kind of thinking of this spectacular set of possibilities. Is it possible, given what Patterson found with the field effects in the vicinity of a working cold fusion gadget, that it has this side effect on atomic nuclei to where it inhibits or it changes or it accelerates nuclear decay? It
induces the beta decay by flipping nucleons. The magnetic component gets stronger and flips one.
Okay, so Frank, is it possible to use this approach, this technology, to interfere selectively in, for instance, the ability to create a nuclear weapon? Could you create a suppression field that you could put in every city in the United States or all over the world, to where if that field was operating and it was powerful enough, there would be no way to bang off a nuclear weapon within the field?
I don't know that. But there's going to be many amazing things.
Well, think about it. Is there anything in what you know that would prohibit that as an end product?
Well, the only thing that I know is in reported UFO cases, it turned the power off. And if that was a gravitomagnetic field, why would it interfere with the electrical current? That's the question I asked myself, and I don't know that. But just from some anecdotal evidence of what people said, there might be something there. And if we could suppress the electromagnetic field, we can suppress other fields. We could do a lot of things. But I don't know. It's getting way beyond where my knowledge is.
But does it intrigue you?
Oh, the whole thing does. I was brought up...
I mean, you understand what I'm saying. If this technology could interfere with nuclear chain reactions, then you could prevent a nuclear global thermonuclear war.
Well, I think if people are wealthier and they have energy, they don't want to go to war. They have too much to lose. People fight when they don't have anything. But if you have a nice life, why would you want to fight? And that includes countries. Once in a while we get a crazy nut that wants everything. And that's a problem in a nuclear age.
I'm not sure that I buy that totally. You know, when we're looking at this whole ISIS terrorist phenomenon in the Middle East and their use of social media to attract lots and lots of followers, a lot of the people who are signing up, who are leaving the suburbs and well-off middle-class existence, have everything material, but they're missing something else, Frank, so they go and join this loser cause because the loser cause says, come with us and you'll be somebody. So it's not just about material wealth or what they can eat or what they put on their back. There's a missing component that is part of the reason why the planet is sliding closer to a lot of catastrophes, because when you give ordinary people the technologies of gods, you got to expect that a lot of them might, if they're not playing with a full deck, they could really do serious damage. Because, again, for every technology which has a positive application, there's always a way you can use it to kill people.
Yes, the technology is a two-inch sword. It can be used for good or bad. It's our choice to what we want to do. And the more powerful the technology, the more good or the more bad it can do. For instance, cold fusion wouldn't be usable for a bomb, but if it's an infinite energy source, somebody can build a little airplane, like a model airplane, and fly it around the world and dispense...
Yeah, but they can
agents at remote locations.
Yeah, so but they can do that anyway. We're talking about a technology which has the potential to become a weapon of mass destruction. And yes, cold fusion, it's really hard. That movie notwithstanding, because the movie had to have a dynamic effect. Otherwise, why make a movie?
Yeah,
that movie notwithstanding,
relatively benign.
Cold fusion is, as I understand it, unless you really do really bad things, you can't really get any kind of an explosion, and then the worst you would get would be a meltdown of your basic reactor. So you wind up.
Fusion has to do with vibrations in a solid.
Right.
And as soon as you start to destroy the solid by getting it too hot, it goes away.
It's basically a self-limiting process. Yeah, so you can't make a bomb.
Right.
But if you can, with that same underlying physics, if you can create beams, think Podkletnov, that could reach out and literally make obsolete a nuclear fission or fusion reaction, so a bomb could not work, wouldn't that be an astonishing breakthrough for the human race?
Oh, it would be. We've got to stop this global warming. There's a lot of things.
Well, the global warming thing, if you can replicate in every basement a 5-kilowatt generator that's pulling energy out of something, then the global warming thing will automatically go away as more people choose that energy source as opposed to clunky and dangerous and expensive fossil fuels, wouldn't you say?
Yes, and I've been waiting for this.
Yeah, but you can't wait. In other words, back to the political game of prediction, what do you see on the horizon that's moving us in that direction?
I see a lot of individual inventors spending their life energy doing experiments and producing results. But I see also some professional people like George Miley and Mike McCubry who've analyzed some of these things and say we've got transmutation products, we've gotten tritium coming off of these things. And so there really is something going on. And I am really surprised that the mainstream hasn't noticed. Matter of fact, if I go somewhere and say, talk to a college professor and say, what do you think of cold fusion? He'll immediately say, oh, that was proven wrong years ago.
Right.
So that's the mindset. It needs changed.
But how do you do that? Saying it needs change is one thing, but doing it, I mean, obviously our educational efforts and our communications efforts are not effective if the mainstream still thinks that these cutting-edge technologies are just, fantasy land.
Yes. What I did is I wrote scientific papers and I wrote a book. I did my part.
Why don't you take some time here?
I don't have the resources to really follow through with the experiments.
Why don't you, maybe we could, help in that direction. Part of the things that I want this show to do with some of the resources that people will be providing us with the subscriptions is to take that money, if there's any left over, and actually apply it to people like you that can do cutting-edge experiments that are replicable to move the ball forward. We're stuck. I mean, you are aware that the EagleWorks folks cannot accept any public money, right?
I didn't know that.
Yeah, no, they are prohibited by the congressional enacted National Space Act in 58 with amendments from accepting, according to the researchers, Sonny White and Paul March, I believe, have said, both of them separately, that they cannot accept any independent money. Like there are people talking about starting a Kickstarter fund that would privately raise a bunch of capital, invest it in these guys that are doing this cutting-edge work, and let's see where it goes. Well, institutionally, they are forbidden from taking money that people want to donate. So if it was going to be done, it would have to be done outside by people such as you or me or other people that are technically competent to set up a demonstration that can actually show us something.
Yes, but I've been disappointed. I went to conferences in Washington and I said I set the velocity of sound in a nucleus equal to the velocity of light in the atom, and I got all the quantum properties, all the energy levels of the atoms, the intensity of the spectrum, a lot of things. And I thought, wow, it's published. Something's going to happen. It just fizzled. Nothing. Nobody pays attention at all.
Well, would you say, again, they're not paying attention or they're paying very close attention? And what
I'd say it's generally ignored.
Okay. So nobody's individually emailed you or called you up and said, Frank, that's pretty interesting.
Just you.
You're kidding.
No.
Huh.
Well, I do hear from a lot of amateurs, and they have.
Now, what kind of experimental background do you have? In other words, if someone provided you with a pot of gold from somewhere, what would you be able to do with it in the way of replicating some of this stuff? And how much would you need?
I don't know. I tried on my own, and
so you have some kind of a laboratory setup.
Yeah, in my garage, in my basement, I did work, and my experiments did not work. but I've learned from the experiments of others, and I'm just really hoping that Andrea Rossi pulls it off. He's the closest, and he's got some secrets, some tricks to the trade.
Now, he's working on his megawatt thingy. Does he have any kind of a plan or a time horizon for the 5 to 15 kilowatt individual consumer gadget?
1 year. He said he's going to have it out within a year.
So a year from July 2015,
yes,
mid-year next year, the election year in the United States, Rossi's going to stun the world by providing actual consumer, you can buy it at Kmart, portable power for your house that literally is unlimited if you just keep topping off the water in the cell.
He has some investment partners with some big money right now. It's coming.
Okay, you're the second guy in 2 days that said this on this air, so we will obviously have the tape. We'll go back and look. What do you think would be the biggest marker or pacer of that technology curve?
Well, I don't know. I thought it was coming through, and so did Eugene Maloff 15 years ago. We thought we were just around the corner, and here we are. Cold fusion was originally discovered in 1990. That's, what is that, 25 years?
Yep.
So it's been dragging a long time. Well, so is hot fusion, too. They've been predicting it's around the corner. It's always 30 years away.
Always 30 years.
But the cold fusion stuff is pretty simple.
It's interesting you bring up Gene, who, of course, was horribly murdered, and I think his murder was directly connected with his what he was doing, because he was on the verge of some interesting political breakthroughs in Washington. But when he and I would converse on this, he would never go down the conspiratorial doorway. He always would talk about, I think he called, this thing with cold fusion experimenters, that they were subject to what he called inventor's disease. Have you heard of that?
Yes.
You want to describe what it is?
Well, if you have a secret and you think it's important, you don't want everybody to know it because then it's not your secret.
And that's been the hallmark of the field. The alternative energy field is a whole bunch of guys all trying to become Donald Trump, making billions of dollars.
Yes.
And none of them have anything out there in the commercial marketplace. None. But see, that tells me that the approach is wrong. In fact, I have recommended to some of these people who I've had the pleasure of meeting and working with over the years, I've said to each of them, one and all, I said, why don't you forget doing a big system and concentrate instead on what we would call an executive toy? Something that would sit on an executive's desk and just run and run and run and run, and it would become like a conversation piece. Look, Ma, no batteries, no wires, no nothing, and it's just running and running and running. And if you flooded the consumer consciousness, particularly now with social media and YouTube, with those kind of little toys, you would change the dynamic, the social fabric of people who think it's impossible, that it can't work because it defies the current laws of physics, and you'd have your political breakthrough. So why is nobody doing that?
It's coming. George Miley and his company, Lenico, they're trying to produce a smaller device to produce a few kilowatts of energy. I haven't talked to him recently, but he's been struggling with that for at least 10 years, and it's always around the corner, but it never quite gets there. And that's what we're seeing a lot in these fields, including the Podkletnov device and the M-Drive. It sort of bubbles to the surface, and we're almost there. And then a few years later, it fades out of the public view. So we have to have, not only do we have to have technology, we have to have theory so that we understand how it works and we can advance it. We can't go, these are difficult things to build, and we have to understand what we're doing. We can't just go shooting in the dark. And I think that the theory and the technology are beginning to come together.
Okay, well, hold that thought, and we'll come back from the other side of this break with the other side of midnight. And we are back on the other side of midnight. We're going to go to the phones. Frank has apparently stated everything he thought he could get in tonight, and he really did a yeoman service, and he got it all in.
Well,
So,
I'd like to say something else, too.
Oh, by all means.
I'm in Johnstown, Pennsylvania, and it's really depressed here, but we sure got a lot of water. We got 7 dams and all the rain, so if you people are dry out there, why don't you come here? We'll keep you wet.
So let me give out the numbers here. If you want to call us on Skype, you have to dial 505-796-8802. 505 is the area code for the Land of Enchantment tonight, which is clear. There's a gorgeous moon out there. I see stars twinkling. I mean, living in the desert is kind of cool. So 505-796-8802. Or if you want to call us on Skype, it's easy. It's simply Enterprise Mission is our Skype name. Enterprise Mission, one word. Insert that in the appropriate box. Give us a call, and we will answer the phone. So let's take our first call and see who it is that wants to ask Frank what. You're on the air.
Hello. You remember back in the 70s, there was this big thing about cold fusion. It was all highly publicized, and then I think they were trying to get investors, and then it turned out to be kind of a fraud, I guess.
You have to slow down because your phone quality is not very good.
Oh, okay. I'm sorry. Yeah, the cold fusion, there's a big thing in the 70s about apparently they discovered it, but they wanted to get investors, and it turned out to be a big scam, I think.
No. Frank, please,
No.
geez, change this person's facts because he's got the wrong facts.
It's not a scam in most cases. There may be a few scammers. The problem is it doesn't work too good yet. So investors want technology ready to go to commercialization. Government needs to fund fundamental science to figure out what's going on. And that's where cold fusion is. It's not ready for investors to take it to market.
Now, is anybody but the Navy actually funding government cold fusion work these days?
Well, there was Marvin Miles. He was at the Naval's Weapon Lab, and
Right.
he was doing work, but they cut his budget. He was actually sort of doing it in the closet in the back room.
This is China Lake up in
China
Central
Lake, yeah. So
okay.
the Navy was into it, but it was people doing it independently on their own budget. It wasn't officially condoned.
See, again, for such a revolutionary process, it boggles my mind that these scientists attached to these government labs are basically doing it with coffee money down the hall in a closet, as opposed to doing it the way government research is normally run.
That's because people think it's a fraud and a scam.
But see, that's a tautology. The experiments themselves prove it's not a fraud or a scam. If Miles got his results at the Navy and he published, how come he didn't get more funding to do more work and do more publishing?
What happens is it kills your career. Unless you're tenured like George Miley was, you'd lose your teaching position. Mm-hmm. I think Miles was threatened there. They were going to fire him if he didn't stop. I don't know why this happens, because it doesn't fit into the mold, the theoretical mold.
You mean the way science is supposed to work?
Yes.
But Dorothy, we're no longer in Kansas. I mean, you've been in this arena how many years now?
Me, I've been interested in new energy since I graduated from college.
Which is how many years, roughly?
40.
Okay, so in 40 years you haven't figured out yet that the political game is rigged? That we're not dealing with science as we used to know it?
Well, we have to get it unrigged.
Okay, and then the question is, how do you do that?
I don't know.
Well,
I
one
wrote
way.
my book, wrote my papers, and I put my equations, and the math speaks for itself.
All right, one thing you need to do is to describe where people can go and read what you have found. We have a large audience. They're on the web. They've got tablets. They've got smartphones. They've got computers. They're connected. Connect them with where they can go and read about the actual data we're talking about.
Well, if you want to read my paper, it's the Benham Chemistry. It's the elastic limit and the quantum condition. That's free over the web. It's sort of a scientific peer-reviewed paper that's doesn't get into all the details. And I published a book at Amazon.com, Energy, Cold Fusion, and Anti-Gravity. It's very cheap, less than $10, $8 or $5, and it's available in book form or in Kindle form. And that provides some credibility. I think it's a nice piece of work. It starts out real easy, then towards the end it gets harder with math. So I had to put some teeth in it. So it's hard to write a book for a general audience, but still have teeth. And I'm still rewriting, making it simpler.
You have any other question, caller?
A couple quick things. In the Mars mission InSight, scheduled for 2016, apparently they're landing in Elysium Planitia, which pretty much along the equator, but pretty much the other side of the world from Cydonia. And they're saying, well, it's because it's flat, no rocks, and apparently they're going to drill down about 15 meters and see what Mars is made of and how it formed and all those things that, I don't really care about. But that's probably what they're selling to the government. Because when I looked at it, there's this big mountain or a hill right in the flat area. And on one side, it's kind of in the shade, but it looks like a big maw or an entrance maybe to a tunnel with a road leading to it, or maybe a riverbed or something.
When the InSight mission gets to Mars, we could find maybe some equally interesting surprises to what the Curiosity mission has discovered in Gale Crater. I'm going to move on. I thank you for the call, and call us again.
I know politically Hillary promises to do big things. I think her big thing is Mars mission.
Oh, really? Yes. Okay. Let's take another call here, and then we'll ask on what basis do you think she might be looking at Mars? Okay.
Because she wants to follow Kennedy, and he went to the moon, and the next step is to go to Mars, and that's a big thing. That's a sort of, I don't know. She didn't say that, but I think that's.
Okay. Well, it'll be interesting to see if that comes true. Okay. Silvio, what is your name again?
EVP. Larry. Hey, Hoagie.
Hi, Larry.
How you doing tonight?
What's up?
Oh, not much. I just got to say a few things. Recently got into your show. Phenomenal. Been enjoying myself. Secondly, about the cold fusion. Now, I'm not questioning the science, but I'm questioning the people who are trying to push the science. It's so much that I feel that some of these people are using these science, this alternative science, as a way to maybe trick people or fraud people into projects that never go into fruition. Now, do you believe this?
I don't think. Hang on. I don't think I quite understand where you're going. You're saying basically that they're basically grant applicants, and they take the money and they do stuff, but they never get real results, so they can continue to get grants.
Yes, or donations from other people who are invested in these things. I mean, I think this came up to me was not with this guest, but yesterday's guest. I just didn't. There was a sense of falsity to him that the way he was talking, the way and I enjoy you. Maybe not grilling, but I enjoy you.
I don't grill. No, I just ask questions.
Oh no, not.
See, well, look, Sylvia, what I'm trying to lay out is...
I actually love the questions you ask because you... Mm-hmm.
This field is not a level playing field. Frank, correct me if I'm wrong, but from your 40 years and my few more years, I have not seen the normal development from laboratory curiosity to pilot system to prototype to potential operational gadget to commercial device. I haven't seen that in these two areas, the so-called cold fusion area or the so-called breakthrough propulsion area. Neither one of these areas is following what we think of as the normal scientific engineering process, and that rings my alarm bells because that tells me the fix is in. And unless we come up with a political solution, nothing is ever going to get to market because everything will be stopped, probably financially, because they can't get funding to go commercial.
No, that's not true. Bill Gates was over in Italy recently talking to the Italian Atomic Energy Agency, and they're working with Andrea Rossi. And he was over there to see what's going on. And he's interested in funding. And, of course,
Now, how do we know this?
It's all over the web. Bill Gates was in Italy looking at cold fusion.
Okay.
And he's good friends with Warren Buffett. So people with the money are starting to look.
Well, that's intriguing.
I mean, they haven't moved yet. They haven't done anything but look.
Well, but how long have they been looking? And what are they looking for?
About 6 months.
Well, that's nothing. 6 months?
Yeah.
This field has been, as you just said, since the 90s for 20-some years. I mean, I was in, what was the congressman? He was the chairman of the House Science and Space Committee. David Livingston, I think his name was. I was in his office discussing cold fusion the very afternoon that the press conference that Hans and Fleischmann held at Utah was on the air. And we were discussing the potential breakthrough that would represent for space travel. He left Congress. He never ran for anything again. His pronouncements on Cydonia, our Mars work, which were very avant-garde in that era, went by the board. No one paid attention. In other words, he seemed to suffer a career price for championing both cold fusion and our kind of novel approach to what NASA has found on Mars. Yeah. So there was a political price to pay. Anyway, thanks. Thanks, Silvio. We will talk to you again.
All right. Thank you for having me. Y'all have a good night.
You too.
You have a good night too.
Thank you.
Okay, let's take our next call here. If I can figure out my screens. Every time I try to go for a call, the screens they go behind each other and I can't see the thingy, so let me move this.
It's about
there we are.
4 o'clock in the morning where I am. I hope I don't start babbling.
Oh, I wouldn't think. You only got about a few more minutes anyway. So let's take Martin Mean Green. That's a name.
I mean.
Mr. Green, you're on.
Yes.
Go for it.
Mr. Hoagland.
What can we do for you this morning?
I'd like to talk to you about, the guest you're talking to right now. I can tell that you already know everything that, there is to know about this energy.
No, I don't. I didn't know that Podkletnov was irradiating his spinning disk with 3 megahertz radio waves. That's really important.
Well, what I'm getting to is, you have a lot of background knowledge going all the way back to the 90s about all this stuff. So, I mean, in a lot of ways, you're trying to school these guys. I can tell.
I would not agree. That's a strange assessment. Frank?
Well, another thing I'd like to bring up is, why don't you bring up a little more information about this UFO diaries and these other faces on Mars?
Oh, I see. You're one of those people.
No, actually, I'm not.
Well, because there's nothing there. There is no there. There is a zero story there. And since I've been in this field for 30-some years, fighting the good fight with NASA, if there was a there, why would I be sitting on it? Why wouldn't I be talking about it on every show, on every network, in every science conference? Why would I be hiding data when, in fact, I'm dedicated to bringing data out?
Well, the main thing is you've never really, answered about the 2 producers of that video that you were in.
Look, this is not part of our conversation with our guest tonight, so we'll tackle this at another point. So okay. let's talk to...
Anyway, when I was a young man, I looked up in the sky and I saw it looked like the full moon flying. It scared me. I thought it was Armageddon coming, and it flew over Johnstown and made a big hole in Kecksburg. It actually landed, and the military took it away. They think it was a Russian nuclear reactor.
Oh, wait. You were there for the famous Kecksburg incident?
I was in Johnstown, and I looked up and I saw this thing flying over. I was maybe in junior high school.
What did it look like?
Looked like the moon, about that big. It had a pretty high radius, and it was flying south. And I was just recently down in Kecksburg to the a winery. It's a Stone Villa winery. I went down there and they're having their UFO days. They're still celebrating, and there's still a hole in the farmer's field, so we don't know.
Well, we don't know what it was. I mean, the assumption was that it was a re-entering Russian spacecraft, right?
Yes.
Yeah.
Something was glowing. I did see that. So
But,
for all
but
you
to,
UFO
to
buffs,
be the size of the full moon, now was it flaming? Was it a hard edge, or was it?
it looked like a quarter in the sky, about that big. It's about as big as the moon, and it was glowing bright like the moon, and it was traveling not as fast as a shooting star, but at a very high rate of speed on a ballistic trajectory. It wasn't changing direction, and it was going from north to south, and it was out of view. I thought it crashed over the mountain, but it went about 50 more miles and landed just south of where I live.
Did it have a tail?
No tail.
Oh.
That was a long time ago.
Oh, that's interesting, because I would have thought with a re-entry it would have had some kind of a, but maybe not. All right, let's take our next call. Okay,
go ahead.
We've got a Mr. Nick Miller. Mr. Miller.
Hey.
Good morning.
Hey, hello, good morning, Mr. Hoagland, and I'm just going to say Frank Snyder.
Okay.
Hey, so quick question. Have you heard anything about 3D printers providing free energy, or is that just nonsense?
Frank?
I haven't heard anything.
Me
I
neither.
keep hearing they're going to change our economy, but I haven't.
Well, I've had this running discussion, dialogue with a friend of mine. I think the 3D printer phenomenon is a niche phenomenon. And I'm using myself as the guide. Do I want to go to Kmart? Do I want to go to Radio Shack or Circuit City or, Macy's or wherever and buy something? Or do I want to assemble the powdered material, spend a couple of $1,000s on a gadget that sits on my desk, and at best can make one or two of something, and then only a part of the one or two of something? In other words, I don't see a huge cottage industry of people making things at home. I do see 3D printing in industry to be very valuable. I mean, they're now using it. Musk is using it, I think, to actually produce some of his rocket engines or thrusters in a unified monocoque way without having to weld or bolt sections of a gadget together. And that seems to me to be a major advance. But the idea that you would have thousands or millions of people all over the country making stuff on their kitchen tables, I just don't see it. For one thing, you have to take as much material and give it to each individual consumer to make a gadget as you do if you're making it in some central plant. But individuals are not set up to manufacture and to get rid of waste products and dangerous chemicals and other stuff that would be, an offshoot of the process. So yes. I don't see 3D printing as a home application really ever doing more than the hobby market.
I guess there's this guy on YouTube. I won't give his name because I don't want to plug him, but he has this machine, I guess that's a 3D printed machine, and it consists of a whole bunch of little, I guess, like bobbin generators and spin motors and magnets. And I don't understand the science behind it, but he's making all these claims.
So wait. So he's built a gadget. How he's built it is secondary or completely separate from what the gadget is supposed to do.
True.
So he's using a 3D printing technology to make it at home, but he's really doing something unique that's totally separate from how he made it.
Right.
Okay.
I guess that's, yeah. But I confess I don't know a lot of details on it. I was hoping maybe you guys might have just heard
Well,
of it.
It sounds to me like there's no connection other than he's using the printer to make parts.
Right. But that brings up a kind of a fascinating idea in itself, I guess.
I have a friend, Howard Walker, and he's got a bunch of rubber tires, and he's trying to get the sulfur out of them, devulcanization. He's working with an investing group, and he wants to make a 3D printer rubber wire, 3D printer ribbon. But you can't use rubber once it's vulcanized. So I've been watching him. He's got this rubber and baked out the sulfur. He has some method he does it, and the rubber looks sort of like chewing gum. Like when it's done, it's soft.
Mm-hmm.
But can you find it? Can you find it at Kmart though? That's the question.
Not yet. But there's a lot of people looking at this and trying to find sources of raw material and hopefully get the United States manufacturing program back on its feet.
Well, if superconductivity is the key to creating a Bose condensate, then room temperature superconductivity should be an extraordinary technological breakthrough in creating these energy technologies and also in manipulating gravity if you could do it at normal temperatures.
Yes.
So what kind of experiments would you envision that would let us know whether that was a profitable avenue to inquire?
Well, I've actually got superconductors and vibrated them and subjected them to fields and looked for anomalous energy.
And
I didn't see any. And so there's a lot to know about materials and systems and quantum physics. And I think I'm just at the start of this as of an understanding, saying it's this vibration of a superconductor, and that vibration produces a velocity. It's the same as the velocity of sound in the nucleus. So those are like revelations. Then I say if you take that velocity of sound in the nucleus and set it equal to the velocity of light in the atom, you get all the quantum orbits. And so I've done that. But it's going to take a lot more. Material science people, either minds, even the atomic bomb, the first ideas were incipient, but it took more and more and more people to finally push it over the line. And the low-hanging fruits in technology have been picked a long time ago by Edison and Tesla. And this cold fusion, even though it's remarkable, it's sort of like the transistor. It has to be done just right. And the transistor didn't come about in the lab. It took lots and lots of money to really get them operating reliably and consistently. So,
well, if Rossi comes out with a commercial device, either his megawatt, unit or the smaller home unit, they will be picked apart and analyzed, and people will descend on them and look at every facet, and there'll be efforts to replicate, to avoid the patent in infrastructure, but to replicate. In other words, you need something that is widely distributed that people can't say, oh, it doesn't exist, it's not working, because there it is.
Well, you know what the biggest secret with the atomic bomb was?
That,
and that is
that the bomb can work.
It's possible.
Yeah.
And once we know that this is possible, that's going to open up the floodgates, and who knows what direction the technology will take at that point. It'll just keep going. But we haven't reached the point where we know it's possible. We dropped the bomb, we knew that was possible. You couldn't miss it. But this cold fusion, even though it's produced tritium and transmutations and
see again the difference in the approach between the Manhattan Project and the Manhattan Era. And there was a really excellent fictional series run on WGN out of Chicago last year, talking about all the soap opera behind the scenes in the Manhattan Project and the scientists that went up here to Los Alamos and camped out in the desert and created the bomb at the end of the war. That methodology, that curve of development from initial wild-ass theory to actual reproducible hardware that did what it was supposed to do, that has not been replicated since World War II in these even more shattering and paradigm-changing technical areas, and I'm asking the question, why? Something's different.
I don't know why, but since 1990, the entire Internet has sprung forth. Technology and computers have revolutionized the world. Since the discovery of radioactivity, which would be maybe in the 20s, when they started really getting in, it wasn't 20 years later that we had nuclear weapons. So this cold fusion has been dangling now for 40 years, and it has a tremendous possibility, but it doesn't seem to be able to make it over the line.
Well, maybe we haven't quite lived long enough. Anyway, Frank, I really enjoyed our conversation tonight. I hope you will come back and share more with us in some future date.
Thank you, Richard.
I would also like to remind people, if you missed any of this show, if people tell you next morning, oh, you fell asleep and you missed it, you can go to the archives, subscribe to The Other Side of Midnight, and you can listen to us any time of day or night or on any gadget. Any closing thoughts?
Hey, Richard, I don't know if I'm still supposed to be on the line or not, but I just want to say you have a fantastic show, and your friends at X are behind you all the way.
Well, thank you so much, Nick, and you have a good night.
You too. Bye-bye.
Good night, Nick.
And I think on that note, we've got a couple of minutes here. I'm really looking forward to tomorrow night. I want to bring everybody up on what we're going to do. Tomorrow afternoon is when NASA's going to unveil another set of images from Pluto. And I'm going to have two special guests, Keith Laney, who you've already met, and my friend Bob Harrison from Britain, who has done some excellent imaging work and kind of looked at comparative arcologies. And we'll define that tomorrow night when we join you and you join us on the other side of
We
midnight.
love that heart on the bottom of Pluto.